All right, hello. So today in class I gave you the cardstock with all these graphs on there, and it also has a backside we'll talk about. So we're going to start off looking at the sine function. We're going to do sine, cosine, and tangent, or maybe just sine and cosine. I'll just see how long we have and whatnot. But anyway, get your unit circle out. So these x values right here, these are going to be angles. And so we're going to go around the unit circle, and for instance, when we're at angle 0, we're going to try to see what the sine is. So we're going to be looking at the y value on the unit circle. So remember, because this is our function that we're graphing here. All right, so, whoopsie. So that means that I have to graph at point 0. So at angle 0, the sine is the y value. Well, if I look on the unit circle, the coordinate at 0 is 1, 0. So that means that the y value is 0. So that's on my graph, 0, 0. Now also look on the graph I have numbered here. I have my x-axis numbered with angles because that's going to be what my x values are down here. And my y values are numbered with 1 and 2. Now, it is a little bit distorted. For instance, like, pi is 3.14, and that looks like about as big as this is right here. So I think it's a little bit distorted. Like, it needs to be wider, but I just wanted to be able to fit it in there. So we'll look at Desmos in a minute, too. All right, so let's go to pi over 2. Well, at pi over 2, the sine's value is 1 because the y value is 1. So pi over 2 gets us a 1. And at pi, the sine is 0 again. And at 3 pi over 2, the sine is -1. The y value is -1, so we're down here. And back to 2 pi, same thing at 0, the sine is 0. So these are going to be like our 5 main points here. So I want you to remember that the sine starts in the middle, so it goes middle, high, middle, low, middle again. So we're going to go ahead and graph that. That's our sine function. Now we could graph everything in between, but these are just like the nice highest and lowest points and things like that. So there are some values in between I'll talk about in a second. So let's go here, graph that. All right, and then backwards we could also go here, just follow the pattern. Okay, for instance, if we had picked, let's say, I don't know, 60 degrees, the value of the, I'm sorry, I wanted to say 30 degrees. So the y value at 30 degrees is 1/2. So if I went to 30 degrees, which would be about a third of the way here, 30 degrees would be 1/2. So you see, like, the point is there. It's just we're cycling through it and, we're going past it. We just did some of the easy ones down here. All right, so let's look at the graph that we have. So we have all these things that distinguish our graph. So our domain, this graph, it just keeps going and going and going. It follows this pattern, like up and down, this little, curve that is happening. It repeats itself on and on and on forever. So the domain is all real numbers. You can do the sine of anything. But the range, if you look, the range is here to here. So the range, the sine of anything, any angle you want, you can do the sine of any angle, but it would only produce an answer between -1 and 1. It is continuous everywhere. So this thing is totally continuous. It just keeps going, going, going for any x value. Is it even, odd, or neither? So let's look at this. Everything on the right is opposite of what's happening on the left. So if you remember, that is called an odd function. Okay, because when you go to some place on the right, you get the opposite of if you went to the left. Okay. All right. Any discontinuities or asymptotes? None on here. Sine and cosine are very simple that way. Period and amplitude. So these are things that we'll talk about. We will have talked about in class when you're watching this video. But the period. So the period is the amount of time, I guess you could say, that it takes to start repeating itself. So from 0, it's going to keep going different, and here. And it's going to start repeating itself. It's going to go on and on again, and then do it again. Oops, that's ugly. So the amount of time that it took to repeat itself was from here to here. So it took a distance of 2 pi on the x-axis to start repeating itself. So the period of sine is 2 pi. and that can change depending on your function that you're given. The amplitude is the height of the function. Like we saw in class today, it is kind of like the loudness of your item here. So the amplitude is from the center up to the highest point, or you could think to the lowest point as well. But amplitude is always positive. So from the center, the height of the curve is 1 unit tall, and that can change as well, but it's not here. So the basic thing is 1. All right, so there's your basic sine graph. So let's take a look at some of these things. So let me see. First of all, let's go here. If I graph a sine graph here, whoopsie. All right, there we go. All right, and so watch what happens. This is a unit circle here, and I'm going to take this back to 0. And so it's going to start creating the sine graph based on the unit circle values that go around the circle. And so you can watch the red, and it's going to be the numbers of the unit circle. And so watch what happens. So you see it's positive, so it's up, it's 1, then it's back down to 0, then it's to -1 as a sine value, the y value, and then back to 0. All right, so it was kind of cool because you could watch it create itself on that. So you could see the 4 corners that we talked about, and basically everything in between. If you watch the red fraction right there on the top left, you can see all the numbers changing. So I'll play it again. See, it's going up to 1, going back down, and then because your triangle, the height of your triangle, the y value of that triangle is rising and falling and kind of rising negative and then falling, but it's still negative, and it goes to there. So that is just the graph that's how the graph of the sine function gets created. All right, so let's look at some ways that you can change this. So let's see, on Desmos, I have the normal sine graph here, and I have gone into my settings and I have changed my x-axis to be from -4 to 9, and I've changed the step size. So the step size is pi/2. So this is a good setting to do when you are trying to graph these. And the y value, it doesn't really matter, you know, maybe go from like -5 to 5 or whatever. But anyway, let's take a look. So what you see right here is you see the same thing that we just had. You know, if I kind of follow along right here, oops, I can't get it to follow along. Oh, there it goes. So you can see that's what was happening on the little thing I just showed you. All right, and so some important points. Those are important points that we had on our table. All right, now watch what happens if I put a 4 in front of my problem. So look at that. So that changes the amplitude. So that makes, like we saw in class today, it makes something louder. It still is repeating in the same amount of time. So if I go here, it still does its 5 points. It's still finishing a rotation or like a cycle in 2 pi, but it is stronger along the way. Okay, and so look what would happen if I put a -1/2 in front. So do you see it's shorter? It's like lower in volume, I guess you could say. The height is only from 0 to there's not a point right there, but you can see that the highest place it goes, or the amplitude, is 1/2. I can't get it to go on there. There it goes. So the highest place it goes is 1/2, right? And then the lowest is -1/2, but the distance from the x-axis to the highest point is 1/2. Now, you'll notice there's also a negative in front of there. This repeated itself within 2 pi, but it was also upside down. So you see it got reflected over the x-axis, right? All right, so let me turn that one off. So back to our regular sine function. So the next thing I have for you is going to be the sine of, and I put a 4 inside with the x. So look at that. So that blue one, if you look at the blue one, it went from here to here to here to here to here. It finished its cycle in pi/2. Pi/2 was the amount that it needed on the x-axis to finish one cycle. So that's called its period. Its period got changed to pi/2, and I'm going to show you that on this other side of your paper. So when you have a sine and a cosine function, the normal period of sine and cosine is normally 2 pi, all right? Is normally 2 pi. So whatever number is in front of x, and this thing's a little more complicated. There's a c and d, so we're only talking about these two things right now. whatever number is in front of x gets divided into 2 pi. So look at the last graph we had. The last graph we had on Desmos there had a 4 in front of the x. So if I go and I say to myself, okay, well, let's see, 2 pi divided by 4 turns into pi over 2. Well, look at this graph. This graph, that's how long it took to finish a cycle right there, pi over 2, right? It took that long to finish, right? And so let's look at the next one. So that graph was very tight. The graph got squished in. Let's see. So in class today, that would have been like a higher note, right? Because it was more, the frequency was higher. It was like repeating itself more often. Whereas if I do this one, sine of 1/2, it's longer. So so what happened there is, if you look, it went from here, from 0 all the way to 4 pi it took to repeat itself. So look at that number in front of x, it's 1/2. So to figure that out, what I would do is I would take 2 pi and I would divide it by 1/2. Well, that turns into 2 pi times 2 over 1, which is 4 pi. And that's why it took 4 pi to repeat itself. All right, so the number in front changes the amplitude. It makes the graph taller and shorter there, or lower there. And then this number right here changes the period. If it's a number bigger than 1, it's going to make the period smaller. If it's a number less than 1, it's going to make the period longer. Okay, so that's just that. And this acts the same for the sine and the cosine graph. So let's look at one that basically has those together. Okay, so in this last one I did right here, I changed both. So let's look back at the center again. So let's take a look, the period. So I can look on here, silly thing, there. So 0 is where it started, it went up high, low, there. Oh, so the period was pi. It started repeating itself after a distance of pi. And look at the amplitude, it went all the way up to 3 up here, okay? So that 3 was because there's a 3 in front. The period is pi because of that 2 next to the x. So look back on our stuff here. If I were to take 2 pi and divide it by the 2, this comes out to pi. So that was my period there. Okay, so the period and the amplitude is what we're dealing with here. The other things we have to deal with later are what are called a phase shift and a vertical shift right there. All right, and so let's take a look at the cosine. So on the cosine graph, we have something very similar happens. It's kind of like a sine graph, but you're going to notice that it's kind of like shifted over in a way. So again, look at the angles on the unit circle with me right here. So at 0 degrees, the cosine is 1 because the value, the coordinate at cosine at 0 is 1, 0, so the x value is 1. At 90 degrees, the x value is, it's 0, 1, so the x value is 0. So let's graph these 2 points. So 0 is 1, 90 is 0. At pi, the x coordinate is -1. So pi is -1. At 3 pi over 2, the x value is 0 again. And at 2 pi, the x value is 1, just like it was at 0. So back up to here. So cosine starts at a high point and comes down through the center, goes to the low point, comes back to the middle, and goes back up. And so really, if you look at the sine and the cosine graph, they're pretty much the same because all around the unit circle, the sine and the cosine values are the same numbers, they're just in different places. So it's just a different time that it hits that value, but it's that value. All right, so we can kind of repeat ourselves over here, just to draw it all the way. So I like to think of cosine, it starts high, middle, low, middle, high. Whereas sine goes middle, high, middle, low, middle. Okay, so cosine starts at 1, sine starts at 0, and it goes through their cycle. Oops, 2 pi is 0. No, 2 pi is 1. Oops. Okay, so just like the cosine graph, just like the sine graph, the domain is -infinity to infinity because it goes forever. It just keeps going over here and keeps going here. The range is -1 to 1. It is continuous. There's no discontinuities. Is it even or odd? Well, look, the right side is the same as the left side. So that is what an even function is. The period is also 2 pi, and the amplitude is also 1. Okay. All right. So let's take a look at the cosine graph on, what was I doing? Cosine graph on my website. That's what I wanted. So just like before, I can do the cosine, and if I take this back to 0, clear that. So watch what happens. So remember, the cosine starts at 1 because the value of cosine at 0 is 1. So there's 1. It's doing, so notice the cosine is the x value. So you have to watch the distance from the center out to the side of the triangle. So you're watching the distance from the center out to point D on this picture. And it's, going around and around. There's point D. It's getting closer to 0. Then point D is getting more negative out to 1, -1. Then it's getting closer back in. So you see the cosine coming back up to 0. And then finally it's getting higher and higher and higher, closer and closer. D is getting closer to 1. And so that takes you through the cycle of the cosine graph. And it just keeps, you're just watching that point D get closer to 0 and further away from 0, closer to 0, further away from 0. Okay? All right, because cosine is the x value. All right, so the last thing we have to do is look at the tangent graph. Now, the sine and the cosine look like so similar, okay? But the tangent is a little bit more difficult, and also more difficult like on your what's it called, your unit circle. So remember that the tangent is the y value over the x value. Well, the sine is the y value, the cosine is the x value. So when I do tangent, and we've always been saying that tangent is the y over the x, well, that is just the sine over the cosine. So that's kind of like a rule you have to remember. The tangent function is just the sine value divided by the cosine value, the y over the x. All right, so let's take a look at that. So anytime that the cosine right here, anytime the cosine is 0, I'm going to have a problem because I'm not going to be able to get an answer, right? Whenever the cosine was 0 and we were trying to do the tangent, remember we would get undefined. So let's look back here. So the cosine being 0, that happens here and here, and also there and there. So all those places are going to be undefined. And when something's undefined, what happens on a graph when a place is undefined? Well, we get an asymptote. So let's go ahead and draw some asymptotes at pi over 2 and 3 pi over 2 and so forth. So pi over 2 is going to have an asymptote. 3 pi over 2, another asymptote. And we'll do one over here. So there's asymptotes all the way. And it's, it's cyclical like the others. So the asymptotes keep reappearing. And notice the distance between the asymptote right here. That's the distance of pi. Because it's like pi over 2 one way, pi over 2 another way. So a half plus a half is a full pi right here. So it's a full pi. So the period of tangent is pi, because every asymptote is going to start all over again. The amplitude, you can say 1 right here. It doesn't really do a whole lot like a sine and cosine do. All right. So let's take a look at one more thing. So every time that the sine is 0, then that means that the whole fraction is going to be 0. So when the sine is 0, because it's going to be like 0 over 1 or something for cosine at the corners. So whenever the sine is 0, then my answer to the whole tangent will be 0. So whenever the sine is 0 in these places, the tangent is going to be 0. So that means right here, right here, right here, tangent's going to be 0. So we can mark that as a spot on our graph. Oopsie, right there, right there, right there. All right, so at 0, the answer is 0. At pi over 2, it's undefined. All right. At pi, on the unit circle, the coordinate is -1, 0. So if I do my sine over my cosine, I get 0 over 1, so I get 0. At 3 pi over 2, undefined. And back at 2 pi, it would be 0 again. It's right there. So I'm going to show you on the other screen what the tangent looks like, but we're going to go ahead and graph it right here. It kind of looks like a cubic function. So if you think about it, at 45 degrees, the value of the tangent is equal to 1. Now my graph is a little bit skewed like I was talking about earlier. So pi over 4 is right about there. The value should be 1. So what the graph does is it comes down, it goes through there, and goes like that. And it comes down, goes across, and goes like that. Ooh, I'm doing a real bad job here. Comes up, kind of looks like a cubic function, and goes back up. So you'll see it's kind of like snakes over. It starts on the left and snakes over to the right. These ones are a little bit ugly, but you'll see on the next page. Okay, so let's take a look at that real quick. All right, so remember the tangent, you're not going to be able to see the tangent one really that good, because remember the tangent is the ratio of the y value over the x value. So you can watch the green thing on the side, it's going to do it. But basically it's not as easy to see because it's the fraction of this point right here. So it's basically the distance from C to D, and then the distance from the center out to D being divided. So I'll just go ahead and like let it play. It goes like that, and then it comes back up, and it starts coming back up on the other side. Okay, all right. So I also have it graphed on Desmos here. If you want to see that, let me turn these off right here and just show you the tangent graph right there. Oops. All right. So this is what it kind of looks like. You saw what I meant about the little curves there. So you notice that every pi over 2, 3 pi over 2, 5 pi over 2, those are the asymptotes. Okay. All right. So let's go ahead and finish this up. This is the last one we're doing. So the domain. So the domain is all real numbers, but x cannot be some things here. So notice that x can't be pi over 2, can't be 3 pi over 2. We need a way to say this because I can't go and name every place. I mean, there's like, it happens like over and over and over that I can't use certain values. So I'm going to say that the first thing I know is x cannot be pi over 2 plus, now what we're going to say here, how you do this is you say pi over 2, so this spot right here, plus every distance of pi after that. Every distance of pi after that. So we're going to say pi over 2 plus every distance and minus every distance of pi. So how you say that in math is you say pi over 2 plus pi n. So that n right there is an integer. So basically what's happening to you is you're saying pi over 2 plus every multiple of pi after that. So what after or before that? So what that means is starting at pi over 2, every distance of pi after that, and then after that, and then after that, or every distance of pi before that, you're going to see another asymptote at those spots right there. So that's just how you say it. All right, the range. So these graphs, once they get created, those blue graphs right there, they just go up and down forever. So the range is from negative infinity to infinity. The range goes up and down forever. Continuous or discontinuous? This is definitely discontinuous. Is it even or odd? Well, if you look at the graph, things that happen on the right is opposite of what happens on the left. So it's like the sine function. It is odd. Discontinuities are asymptotes. These happen at pi over 2 plus every multiple of pi after or before that. Remember, n is an integer. So n can be numbers like, negative 2, negative 1, 0, 1, 2. So what that does for us is it creates asymptotes at every multiple of pi that's after pi over 2, every distance of pi away from pi over 2. Okay? All right. So there's those three graphs. We're going to be studying sine and cosine to start with and change amplitudes and periods and things like that. The period of tangent is pi, so that is a little bit different than the others. But, if you're going to do the period like we did over here, you would just take pi and divide it by the b value instead of doing 2 pi divided by b. Okay? All right. I'll see you in class.